Great, so I'm going to kick it off to our excellent panel. We're going to talk about blockchain. It's going to be highly interactive. Jay here is going to walk through how the blockchain works to a high level through an activity. So you can put your laptops away because you're going to be doing things. Katie in the back has some hand sanitizer and napkins because we'll be touching newspapers. So if you're like not into it, you could just get some napkins from her in the back. And then we'll do a panel, but it'll be similar to yesterday where I will be running around with this mic and you get to ask questions and they will answer. Sound good?
Yes.
Awesome. Kick it off.
I'm going to introduce Jay Carpenter, who comes to us from Phoenix. Jay is the progenitor of the Desert Blockchain group, which is the largest blockchain meetup in Arizona. Jay knows seemingly everyone. I've never asked him about a project that he didn't know the principles of, it feels like, but also doesn't own any cryptocurrency, so he's truly neutral and cares about the tech very passionately, which I always found to be unique in this space where the crypto bourgeoisie own and rule all. So Jay's going to take us through a very nice simulation of how a blockchain works through the use of newspapers. And why don't you take it away, Jay?
Awesome. Thank you, Russ. Okay, so we hear a lot of talk about this thing, blockchain. And my impression is a lot of people think blockchain and it's this kind of mysterious thing. So I think the best way to learn about blockchain is to build a blockchain. So we're going to build a blockchain using the Seattle Times. So we've got 3 issues of the Seattle Times, and we're going to basically use this as our blocks. And the other thing to keep in mind is that we are all involved in this exercise. Blockchain is a peer-to-peer decentralized construct, and let's consider that this room, everyone in this room is going to be part of this process. Okay? Everybody up for that? Cool. Okay, so first thing I need, or we need, is a volunteer. Who would like to be a volunteer to hand out the Seattle Times, which is going to constitute nodes? Okay, sure. Go ahead. Carl, okay. So the first node that we're going to start with is April 5th. Thursday, April 5th, 2018, Seattle Times. This is something you could obviously pick up on any corner, any newsstand, whatever. So please raise your hand if you are willing to be a node in this blockchain. So just pick out 10 people and give them an issue.
What's the compensation?
You'll find out in just a minute. No. People that are raising their hands. Now, there's also a need for another person who's going to be doing things on this board, which is actually creating our blockchain. So is that a volunteer or? Okay. Somebody else who would be willing. Okay, Holly, are you volunteering to be a? Awesome. Perfect. So right now in the community, we have 10 nodes that are established, which are the people with the first issue of the Seattle Times. Okay. So we need another person. Actually, Carl, you can do this. The next, we're going to pass out 5 of these tickets. People are going to tear them in half, and they'll put one of the halves in this one. Does that make sense? Okay. And they keep the other one. So now the next thing we're going to do is we are going to create 5 miners out of the 10 people that have a copy of the Seattle Times. So if you have a Seattle Times and you would like to be a miner, will you please raise your hand? There's one. No, just the people that are minors. We want 5 of these. Yeah. So, you have to have a Seattle Times. Number 1, you have to have a Seattle Times. Number 2, you have to be willing to be a minor. And you're going to tear your ticket in half. We need 5 minors. Put, half the ticket in the jar. And then we're going to create our first block. So, do we have, okay, awesome. So, just to recap, let's take a look at what's happened so far. Number 1 is we are all part of this as a community. Anyone in the room could have raised your hand to be either a node or a minor. That's called permissionless. It wasn't Jay up here pointing out, okay, you be a minor and blah, blah, blah. That's a centralized construct. We have basically a ubiquitous participation of a community that constitutes everybody in this room. And that's a key thing to keep in mind in the blockchain realm. So, now we're going to create our first block because we have 10 nodes and out of those 10 nodes, we have 5 minors. So, Holly, will you take one of these pieces of paper and put it about 6 inches from the left and about 6 inches down. Yep, right about there. Okay. And first thing to do is put a 0 about 3 inches down from the top, and the 0 should be about 2 inches high. Just a 0. Yeah, exactly. Okay. So this is what constitutes our Genesis block. Okay? So we're starting with a permissionless community, and we are starting from 0. The other thing to keep in mind is that anyone can create a blockchain. And part of the cool thing is if it's very similar to creating like a neighborhood newsletter. It's that simple to create a blockchain. Now, getting people to read the newsletter, getting it to the circulation and the attention of the Seattle Times is a different story. But part of what we've just experienced is the ease of starting a blockchain. So, this constitutes our Genesis block, okay, which is 0, the start. And now we're going to put transactions in that block. So, the thing to do is, Holly, will you please pick a number?
2017 069.
069. So who has 069? Okay. Okay, cool. You can stay right there. Stay right there. You are the first miner. And you are going to determine the content of the first block. And step number 1 in that is, in that section that you have of the Seattle Times, pick a page, any page, and rip it out. And tell us what that page is. Actually, you're gonna pick 2 pages, 2 full pages to rip out. So pick any 2 pages, tell us what that is. Yeah, full pages. The key thing is we need the page numbers. So it would be like page 11 and 12, and then maybe page 18 and 19, if that makes sense. And go ahead and tell us which ones, because every other node is going to do the same thing. So what's the first page?
So the front page.
Okay. So that's page 1 and 2?
Yep.
1 and 2, and then what's the next page?
5
Okay, so everybody who has a copy of the Seattle Times should be ripping out pages 5 and 6 and 1 and 2. And you can discard the rest of that issue. And Holly, if you will now, like right about here, put pages 1 and 2, and then another sheet 5 and 6.
Doesn't matter where on the page.
We're going to sum those. So I would stay consistent, start with the first number about 2 inches down, about 2 inches high. Okay? And here's the other important thing. For our minor is going to get a reward. That's right. Everybody who was thinking about being a node and a minor, eat your heart out. So, yes?
But do you have intentionally only 10 nodes? I mean,
No. 10 is just, there are a lot of things that I'm kind of glossing over here. We could have 100 nodes. Bitcoin has, I think, 6,000 nodes.
but there is a finite number.
No. We could have, everybody could be a node. And pardon me? We just don't have that many newspapers. We're just kind of glossing over certain parts. So, good question. And it's a key question. But let's look at another dimension of this. Even though you are not a node, so Paul, even though you are not a node, if you have a question, you can go look at her node or another node, and you can start to compare the difference between the nodes. Because yesterday, a key part of the conversation that everybody is dealing with in this room and in this movement is trust. And what we are doing right now in building this blockchain is we are experimenting with a decentralized realm of trust that is akin to freedom of the press, I assert. So there's a lot of excitement about this blockchain thing, and it's kind of mysterious, but you can start to draw parallels between blockchain and freedom of the press. And what does freedom of the press do? Well, it creates a distributed information source that starts to keep the whole system in check and in balance. Does that make sense? So, the next thing is, very good, we want to sum these two numbers, or these, sum. So we got 3, and we got, 11? And everybody should be checking this. And by the way, you should be checking this as if your family's safety depended upon it. Because although we're doing a simple little exercise, I assert that in cybersecurity, in financial transactions, and other realms, the integrity of what we're building in this little demonstration could have impacts as serious as the safety of your family. Not to be too dramatic. This is going to be fun, but. So, everybody agrees on this? Anybody see any discrepancies? So these constitute the transactions. And now, if I could pilfer your blocks, okay, these two. So Holly, if you would put that under block number 1, or excuse me, transaction set number 1, just tape it like right here. Yeah, right. So does everybody see that what we're doing now is we are building a set of information that the community is coming to agreement on as sort of the source of truth. And we are doing it in a financial incentive set via the mining rewards that puts a vector into this in terms of the integrity of the data. Yes?
So why was he the one to choose the pages, and then how did the other nodes know what pages he chose?
So he was the one that chose the pages because you selected, you are representing proof of work. You constitute a massive amount of energy called proof of work. And through the proof of work process, you are constituting sort of an unbiased random selection. Okay? And we could go into that deeper. But that's a great question. Thank you.
But then how did they know what?
Because we are simulating a worldwide computer network in this room without actually having the computer network connectivity. Because we're all in this room and I'm up here yelling and you guys are, can see what's going on. This is also similar to an auction because we all see what's going on. It's all transparent. Okay? And another key dimension of this is adversarial. Just as somebody expressed a little groan when they didn't get the $5, everybody would like to get that $5. And in the Bitcoin blockchain, it's not $5. It's in excess of $100,000 every 10 minutes. That's huge. So, yes, quick question.
What's the equivalent of a Bitcoin in this scenario? Is it those pages? So he mined a Bitcoin?
Yeah. The Bitcoin ledger, if you will, would be constituted within these pages, if that makes sense. Okay, so.
But the Bitcoin is the dollar you gave.
Yeah, that represents Bitcoin. So we need a little, go with me, we need a little bit of willing suspension of disbelief here, okay? So, Holly, if you would now put these arrows up like this. Okay, and another arrow there. And then take the sum of those two transaction branches and put it underneath the 0. So you've got 3. Yeah. But go ahead and list it out for like auditing purpose. Scratch out the 14 and just put 3 and 11. Right. It's not a hard fork yet. If I don't eventually get a mining reward, we are going to hard fork this. So, just a joke. Anyway, so now put a sum total under here of 14. And here's what we just demonstrated mining, okay, with the random draw. And now what we're doing is we're demonstrating a hash. So this is a very crude hash. Yep, that's the ledger. This is a hash, and this starts to constitute a audit or the immutable part of the blockchain. Can you see that if anybody tried to use any other number of the page of that first section, that total is going to change. So now what we've just done is we've taken something that looks like numbers and we're creating something that's both like an audit trail as well as sort of a fingerprint or identity. Okay, so we have, congratulations, we just built our first block. So. Okay, so let's go ahead and build our second block. So the next step is, let's put this ticket back in because the same miner could win the second block as well. Yes?
When I think about blockchain,
Mm-hmm.
I'm wondering, so far it seems like we're talking about the application of blockchain for currency, for Bitcoin. I'm wondering if there's a difference in how it's being presented as used for a distributed computing.
May we defer that question until bring that up?
All questions related to like the bit larger implications that are not related to this exercise, we put a pin in it.
I want to understand the exercise in the context of my understanding of what
Okay.
blockchain is. So it's just, is it the same for this exercise?
Is it the same in terms of, are we talking about distributed energy, or are we talking about?
The process to create a block and what a block is and what a chain is and what the newspaper represents.
Okay.
Is it sort of the same if you're mining Bitcoin or if you're setting up a distributed energy system?
Great question. No. This is important. The canvas is open. So what we are doing is we're kind of modeling the way Bitcoin works. But your question is, could we actually come up with a new way to do this that fills the same spirit, if I understand you correctly? And are there other blockchains that are using some variation on this process? And the answer is yes. And if all of a sudden the light comes on with any one of us in this room and we can come up with a new consensus algorithm that doesn't use Holly, who is this enormous amount of energy, then we could actually, by the time we walk out of this room, create a huge breakthrough in terms of consensus and this massive, insane computing war and energy burn, if that makes sense. And that's a key point that Paul made yesterday, is that the negative connotation of blockchain in terms of being this enormous energy burn, a lot of people are working to do away with that. So there's a huge amount of creativity that's available out of this sort of paradigm. Okay? So who is miner number 2? 7-3? Okay. Very good. You get the next mining reward, and you get to pick, oh, I'm sorry, we skipped part of a step, which is we need to, Carl, if you will distribute, this is block number 2, the essence of block number 2. If you'll give every single person who has a Seattle Times from block number 1 a copy of that. Yep. Pardon me? Yeah, put it like right there. And Carl, if you will give, okay, you've got a copy, and I'm sorry, I can't remember your name. Tell us which pages.
Sorry, how about
Matt.
1 and 12?
So 1 and 12. Okay, so Holly, if you will take the 14 and put it on the top of that block. Okay, so 1 and 2, and then 11 and 12, is that right? Okay.
One more newspaper, who else got a newspaper the first time?
And if you will give us pages 1 and 2, and then 11 and 12. Okay. So cool. And just paste those up there. And then another key piece that I'm going to do for Holly is we are now carrying forward this 14 to the top of the next block. And that is a key piece of what constitutes the chain. Okay? So what we just did is we now have a numeric or a code carryover from this block to the next block. So now, even though we're adding more information to this second block through these two sets of transactions, we still have a tie back to this. So if somebody tried to tamper with any one of these elements in the first block, that would throw everything off. And if you wanted to try to spoof or fool the blockchain, we'd have to go through that random draw again the first time. So if you will total those two and then put the totals up on the block. So, and then put the arrows in. Does everybody agree with her calculations?
It says 26.
Oh, 20. Oh, whoops, wait.
See? See, that's perfect. There's an instant ability through the transparency to audit what's going on. And all the nodes, all the miners, anybody who's not a node or a miner can basically detect that discrepancy. Okay? So does everybody agree with this?
40 be a sum of 23 and 3?
No, 40 should be a sum of 14, 3, and 23. Is that what it is? I'm not calculating. Okay. So what we've done is we have created a fingerprint of all this information. And that's the way a hashing algorithm works. So with a hashing algorithm, we could actually take the entire Library of Congress, and if so much as a period changes to a comma, we would know that instantly. That is a huge reassurance on what the content is in something like this. Okay? So we have created our second block. Now let's go ahead and create our third block. And then we'll conclude and open it up for questions. And by the way, if I'm doing something wrong here that doesn't make sense, that doesn't hold true to the integrity and the consistency of what you think of as blockchain, please note that. I'm just kind of leading the conversation. Okay.
71.
71. Okay, awesome. You get the last mining reward. And you get to say which pages are ripped out. Oh, I'm sorry, I forgot this crucial step, Carl. If you would hand these out, you can go ahead and.
To all the same people who already have this.
Same people that have a copy of the Seattle Times that are nodes. So. It could be different people. Yep. That's another part that I'm skipping over, is this construct is so flexible that nodes can come and go. In fact, we would kind of want that, because if it was the same 10 people, then it starts to become centralized. So, which pages are people ripping out?
5, 6, 9, and 10.
5, 6, 9, and 10. I'll go ahead and put this up for you. So this is our third block. And we'll want to carry the 40 over to the top of the block, which is the hash of the prior two blocks. And then do the same thing. So we are in the process of completing our blockchain. We have created 3 blocks. We have an entire community that's engaged in the process. Even if you are not a node, you can check the integrity of how this whole construct is working. We're not relying upon a central authority to determine the truth. What we have is truth is emerging through a completely decentralized construct that is adversarial in nature. And if we were a little more dynamic, our mining reward would be fluctuating. So we would also have something called price signaling that would be happening in this realm. And if we really had a coin or a token, the price of that token or coin could be going up and down in value, which also engages the entire community for anyone who cares to follow that particular price movement. So I think that's pretty much it. I think congratulations. The Nori community has created your first blockchain, and that's really, really awesome. Thank you.
Great, thank you, Jay. Thank you, Holly. That was great. Well, you know Jay, and you know Paul. I should introduce Jaycen. He's the principal blockchain architect for Nori. I think you have the busiest LinkedIn of anyone I've ever met, because he's an Ethereum developer, which are in high demand, especially if you're as good as he is. You're blushing a little bit, which is hard to see with your red hair. But we just want to open it up to questions. I'm sure there's a lot after that. That was definitely a good introduction, but it is a tough topic to wrap your head around at first. So why don't we just start with any questions that there might be.
They all got it. They're all they're all as good as Satoshi Nakamoto. I mean,
Yeah.
Yes.
Ask first, and then I'll give this to Keith.
So if I were to run out, if you're doing more rounds of this, and I ran out and picked up another newspaper, could I join the party?
If you picked up another newspaper, you mean if you could start your own blockchain if you created like something from, let's say, the Portland Times or the New York Times or whatever. Is that what you mean?
I think if I ran out and grabbed the Seattle Times from the newsstand.
The one implication that would have is that you would have to also pick up all the other newspapers that were first distributed. So as long as you have from block 0 to the latest version, you could definitely pick up that latest stack of them and start participating and earning some of those $5 bills that Jay has so many of.
Yes. Any other questions? We had.
Alessandro.
Yes. Question.
Yeah, sorry, Keith Postian in Colorado State. Yeah, I don't think I don't get it at all, but so just a few things, and maybe it doesn't really matter, but so where are the, and maybe you don't say file, but there's some kind of information, call it a file, okay? Where's the file that all the nodes have information? Is that sort of somewhere on their hard drives then, or?
Yes.
And so then they're mapped to all the other people that are in the nodes, so that everyone, it's like a giant Google Drive or something equivalent where all the information is, or?
Excuse me for interrupting. Who is a node? Will you raise your hand if you're a node? Okay, this constitutes the database. All these 10 people, and what this ledger that they're kind of syncing up between one another, that constitutes the overall source of truth.
We'll each keep a copy of the entire truth. Okay.
Yeah.
So then if, I don't know what it's called, Sleepy Bear or something manages to join in and become a node and then try to slip something in here. So then are the people that are, I don't know, are they the developers, or who are the people that are checking on, or is it the system checks and says, and comes up with a flashing red light saying somebody's trying to hack and they tried to change the blockchain and you can't do that and now we're kicking them out, or what is?
So,
sort of what happened.
I'm sorry, what's your name again, please?
Keith.
Keith. So Keith, if I stand up here and I say, Keith, you know what? I'll sell you the Brooklyn Bridge for $1,000. You might become suspicious. And when you become suspicious, if you have any inkling of distrust in the system, you would start to double check my statements. So Sleepy Bear, who comes to you and says, hey, I got a copy of the Bitcoin blockchain or the Nori blockchain or whatever, or the Ethereum blockchain, which they're planning to use, it would be your responsibility to double check to make sure that Jay's blockchain, or I guess I'm going by Sleepy Bear now, that Sleepy Bear is actually representing the truth as determined by this community of consensus. Does that open up a...
Yeah, maybe. But so
I think
so I'm kind of a self-employed person that I have an incentive to be, you know, somehow monitoring or participating in this. Yeah.
So we saw that there were two different kinds of people. There were nodes and there were miners. You can't be a miner without being a node, but you can be a node without being a miner. And all nodes maintain the entire history of transactions in this distributed ledger. And it literally does live just as a file on your hard drive that grows and grows and grows. I think the Bitcoin ledger is over 50 gigabytes at this point. It's large.
I think it's probably bigger than
Bigger than that, yeah. I haven't run one in
And
a
the
while.
Ethereum is over 300 gig.
Yeah. So and I think what you're asking is how do we prevent, and this is similar to what Paul was asking, if a hacker tries to come in and assert that, no, actually, there's a different transaction that I think is the one that should be the next block as part of the chain. That is automatically prevented because everyone else is still moving forward because they're incentivized by that $5 bill reward to attach to the existing chain as it is. And this is commonly known as, the most common sort of attack on this type of ledger is known as a 51% attack. The idea being, if you can control, we had 5 miners. If you could control 3 of them, then you could actually take the blockchain in a direction that you wanted to. But the thing is, as these networks grow larger, as there are more and more and more miners, that becomes more and more and more difficult and more expensive for people to do. And so these networks benefit from growing in size, and that makes it more and more secure. And in all the world of blockchains, Bitcoin is the most secure blockchain, although I think Ethereum and Bitcoin have gone back and forth on that because of the size of the mining community that is contributing to it.
So Bitcoin, as of this morning, has a market capitalization, meaning that if you took all the Bitcoin that's out there and you multiplied it times the price of Bitcoin, which is around $9,200 a Bitcoin, it would have a market capitalization of about $156 billion. And the way the blockchain and cryptocurrency community looks at that is they look at it like a prize or a bounty. So if I was smart enough and I could find out a way to defeat the Bitcoin blockchain, I could instantly earn a bounty, if you will, of $156 billion, which might get me through the weekend. But every day that the Bitcoin blockchain is in existence, it's like a hardening of the entire construct because it's constantly under attack. It's an adversarial system. But the paradox is that out of this adversarial system, trust and truth emerges. That is an astounding phenomenon in my view. And it speaks to the heart of what Nori and this entire community is trying to do, which is infuse truth and trust in the removal of carbon out of the atmosphere.
That's a great segue for the next session, which is all about open source and transparency. But before we do that, let's get 2 more questions. We are running a little bit behind, and then we'll switch over.
This is probably related, but
if somebody pulled out the wrong page, what happens to them?
Then they are an odd man out compared to the other 9 nodes.
And they get kicked out?
Well, they don't get kicked out. They're just they just have like a red scarlet invalid across their forehead.
In which case, they're not a viable or valid node for that transaction?
Well, in which case, nobody's going to listen to whatever they have to say from that point on.
Okay. And there's sort of maybe the transaction number or whatever, then there's the content of the transaction. That's all held within one whatever block.
So
the
that's,
content and the tracking or whatever.
And that's where, this is a Bitcoin example, and Bitcoin is simply a currency, and it's just keeping track of debits and credits from one account to another. But Nori is building on the Ethereum blockchain, which takes that to another level, which is instead of having this being a debit and credit, it's actually an execution of a computer program. And so every single transaction in the Ethereum blockchain is an execution of this program, and everyone agrees that this execution happens in that way. So Bitcoin is a worldwide currency, and Ethereum is a worldwide computer. It's a very slow computer, but it's one in which we all see the exact same results from it, so we can all trust that the transactions, which are programs, happen exactly the same that everyone else sees it.
I'm not sure if this was addressed. Can I join this blockchain at any time? Can I be a node and a miner whenever I feel like it?
Yes. Yeah, all you have to do is download the previous blocks that have happened, so you have the full ledger, and then you can start adding the new blocks that are discovered to your ledger, so now you are acting as another node. And if you wanted to be a miner, then you could do the same thing, and you would be running the mining software on your computer equipment.
Great. That's all the time that we have for this session. If you have more questions, we have a networking break after the next one, and you should definitely ask those to our panelists. Thank you.